Hi everyone, and in this video I'll be going through a quick question on direct proportion. So the question says if y is directly proportional to x, and then it says, oh, okay, y equals to 14 when x equals to 2. It then asks us to find an equation connecting x and y, and then it also asks us to find the value of y when x equals to 5, value of x and y equals to 63. But let's first look at this relationship. Y is directly proportional to x. What it really means from this one line is that y equals to kx, where k is some number, or actually the more technical term is that it is some constant. K is some constant where k is not 0. So it could be any number. It could be 1 million, it could be 5, it could be 6, it could be 9. We don't know. We just know that when they tell us y equals directly proportional to x, this relationship must hold. And then it says y equals to 14 when x equals to 2. So actually based on that, we can do part I. Y is 14 when x equals to 2. So we know that y equals to kx because of this line. And y is 14 when x equals to 2. So we sub those values in. You can see that we can solve for k. K is simply 14 divided by 2, which is 7. And that means the equation connecting x and y is simply y equals to 7x because you solve for k. So now let's do part double I. For part double I, since we already know that y equals to 7x, now it says find the value of y when x equals to 5. So we're trying to find y when x equals to 5. So we just substitute the value 5 in. Y is 35. And then for part triple I, the value of x when y is 63. So once again, we start with the relationship that we have. Y is 63. We want to find x. And so 63 divided by 7 equals to x. Or we can say that x equals to 9. There you go. Yep, and just as a little extension, you can see that the relationship when y is directly proportional to x is actually, when we say it's y equals to 7x, that actually gives me the graph that looks something like this. Y equals to 7x, and the gradient is 7. You can also think of this as y equals to mx plus c, but in this case m is 7 and c is 0. That's why it's a straight line. And so this graph actually shows direct proportionality. All graphs, in fact all graphs of direct proportionality where y equals to kx, they all look like a straight line passing through the origin, where k is simply your gradient, and of course your c, if you have a plus c here, c has to be 0. And then you ask yourself, does it make sense? For direct proportionality, we usually expect that when, let's say, when x increases, y has to increase, right? And so we can see that, yeah, as x increases, y does indeed increase. And when x decreases, y does indeed decrease. Yeah, just that for direct proportionality, it happens in such a way that when it increases, accordingly, it forms a straight line. Not a curve, but a straight line. There you go.